Welcome back. This is an Aleks training video on solving limiting reactant problems in solution. If you remember, limiting reactant means that if you're making something, the parts that you make it with either have to be the same amount or you can only make what you have the least of. So for instance, if I'm going to make peanut butter sandwiches and I've got all the peanut butter in the world but only 3 pieces of bread, I can only make 1 peanut butter sandwich. So I'm limited by the bread. So in this example, you're going to make some silver chloride. That means if I have a certain amount of moles of silver to work with and I have a certain amount of chloride to work with, whatever I make, I can only make equal to the smaller amounts of those two stuff. So I can, if I have less chlorine, then I can only make the amount of silver chloride equal to that amount of chlorine. Okay, so the question's a little more complicated than that, so let's just look at it. You've got some sodium chloride, so that's some table salt. You're going to put it in a test tube with a certain amount of solution with a concentration of silver nitrate. Okay, so silver nitrate is soluble in water. That means that it's all dissolved in the water. It looks clear. But if you put sodium chloride in it, it's going to dissolve as well. So like you'll end up with sodium in the water. You'll end up with chlorine ion in the water. You already have silver in the water, and you have nitrate in the water. Okay. Now silver nitrate we already realized was soluble, so it dissolves, and so you're going to have a solution. You know also that sodium chloride, your experience with sodium chloride, that's Na. Sodium chloride it dissolves in water, so it wouldn't fall out to the bottom of the jar. But if you were to combine this sodium with this nitrate, nothing would happen. Okay, because all nitrates are soluble in water, so no big deal. But if you were to combine this silver with this chloride, you would get silver chloride. And silver chloride is solid, and it would fall out. It would fall out as a precipitate. So they're going to ask you a very sneaky question. Very sneaky. I'm amazed at how sneaky this is. Calculate the final molarity of chloride ion in the water, in the solution. Okay, so obviously not all of the chloride is going to fall out as solid. You're going to have some left over. That makes me think that my silver, I'm going to have less silver, moles of silver, than I have moles of chlorine. Then your silver is going to act as your limiting reactant. That's going to make a solid fall out, and then you're going to have some chlorine left in the water, and then you are going to find the molarity of that chlorine. So I stand amazed at this question. So let's first of all find out how many moles of silver ion do we have? How many moles of chlorine ion do we have? All right. So let's take first with what we're given. We have 300 mils of 0.5 molar silver nitrate. If you remember, molarity is moles over liters. All right, so my molarity has been given as 0.5. Moles I don't know yet, that's what I'm trying to find. So it's going to be equal to moles over, and now I don't have liters, but I have milliliters, so I have to divide by 1,000. 1, 2, 3. I'll end up with 0.3 liters. Okay, so this is 0.5 molar, 0.3 liters. So when I multiply these two together, I'll have moles, and this will be moles of your silver. Okay, so 0.3 times 0.5, okay, equals 0.15 moles of silver ion. Okay, so let's keep that for a while. Now let's find out how many moles of chloride ion we have. All right, so we have 22.9 grams of sodium chloride. Well, I remember that sodium, we've got 1 in sodium chloride. The periodic table says it's 22.98977 grams per mole. The chlorine, I've got 1 of those. It's 35.453 grams per mole. So adding that together, I get 58.44277 grams per mole. All right, so let's find out. I've got grams. I've got grams per mole, so I can find out how many moles I've got. 22.9 grams in 1 mole. I've got 58.44277 grams. Grams will cancel. So just a moment. 22.9 divided by 58.44277. Okay. I'm going to have 0.391836 moles. Okay, and this is chlorine ion. All right, so which is the limiting reactant? If you're making this solid, silver chloride, I have this much silver and I have this much chlorine. So how much can I make? I can only make this much. I can only use 0.5 moles of this to make my stuff, and it's going to fall to the bottom of my test tube, and then the leftover, the excess, will still be floating in the water. All right, so let's subtract the amount that's going to fall out. So I'm going to subtract 0.15 moles, okay, of the chlorine, because it's going to be falling out. And I get 0.241836, I'm going to round this off in a minute, moles of chlorine. How much liquid do I have? Because it's per liter. So this is moles. Per liter would be 0.3. Okay. So this is 0.2418 divided by 0.3. Calculator says it is 0.806121071 molar, but I only want my significant digits. There's 3 here, there's 3 here, there's 2 here. So I only want to go to 2 significant digits. So I'm going to go to the 80, go to the 1 beside it. It's a 6. I'll raise that 0 to a 1, and it's going to be 0.81 molar. And there's my amount. Pretty amazing.